Hello and welcome. In this video, we're going to be looking at how to simplify products of radical expressions. So before we begin, let's review a couple of concepts that are going to be key in simplifying the expression that we see here. So the first thing that I want to review is how we multiply like bases. So if I have something like x squared times x to the third, remember that we're adding our exponents to simplify. So in this case, we would end up with x to the 2 plus 3, or x to the fifth is another way to say that. The second concept that I want to review is how we multiply square roots with other square roots. So whenever I multiply square root, say like the square root of 3x times the square root of 7x to the third, well, what I'm going to get is an answer that's still under the square root. So I'm going to multiply my 3x by my 7x to the third, and then whatever I get is still going to be underneath my radical. So 7 times 3 is 21. And then I've got x to the first times x to the third. So if I add those exponents, that gives me x to the fourth. Okay, so notice when I multiply square roots by other square roots, I can multiply the stuff underneath, but then I'm left with the square root of whatever I get for an answer. Okay, the third thing that I want you to recall then is you'll notice I've got the square root of 21x to the fourth, and that's the same thing I have here. So I want to look to see how we would simplify something like that. So remember that for square roots, the idea is that for every two factors, I'm allowed to pull one out. So the square root, for every two factors, we keep one. So 21, as we just saw, can really be factored into 3 times 7. I can't factor either of those numbers further, and then x to the fourth is really x times x times x times x. So when I'm simplifying this, again, for every two unique factors, or for every group of two factors, I can pull one out. So if we look at the 3's, well, I'm stuck there because I only have one 3. So that means this 3 is going to have to stay underneath my radical. The 7, same thing. I've only got one 7, so my 7 is going to have to stay under the radical. But now when I look at my x's, notice I've got a group of 2 and another group of 2 x's. So what that means is I can pull out two factors of x. So on the outside of my radical, I'm going to have x squared. On the inside, I still have that 3 times 7, which is 21. Alright, the fourth thing that I want you to remember is how we multiply fractions. So remember that when we're multiplying fractions, we just multiply the tops together and the bottoms together. So in this case, I would have 1 times 3, and then on the bottom, 3 times 7. And then we look to divide out common factors from the top and the bottom. So in this case, notice I have a 3 on the top and a 3 on the bottom. So if I divide top and bottom by 3, each one of those guys becomes a 1, and if I multiply it out what's left, I'm left with 1 times 1 on the top, which is 1. On the bottom, 1 times 7 is 7. Okay, there's actually one more thing that I want you to recall, which is, say I have the square root of 5x over the square root of 7. Whenever I'm dividing square roots, I can just write that as one single square root. So the square root of 5x divided by the square root of 7 is equivalent to just the square root of 5x over 7. Okay, so let's see how these tools, or these facts, are going to play into solving the problem that we saw originally. So originally we wanted to simplify this thing. So the first thing I'm going to do is I'm going to use that fifth fact, which is whenever I have a square root over another square root, I'm just going to write this guy as one big square root. So my first step is I'm going to leave the first guy alone. The second guy, I'm just going to write as one big square root. So I've got 8w to the 7th on top. On the bottom, I've got w to the 5th, x to the 7th, z to the 3rd, Okay, now I've got a square root times another square root. Well, we saw how to handle that when we were reviewing those topics. So if we look at number 2, if I've got a square root times another square root, I just multiply the inside parts together, and then the square root just stays around the whole thing. So that's what I'm going to do in my problem. So the second step is I'm literally just going to multiply the inside of this first guy together with the inside of the second guy. And notice that when I do that, I've got two fractions. So when I multiply fractions, I'm just going to multiply my tops together and my bottoms together. So here we go. We're going to have the square root of, and then my top is going to be 8. And here's where I like to have my variables kind of in order. So I'm going to have 8 w to the 7th, x to the 3rd, z to the 3rd. So when I say in order, I just mean alphabetical order. On the bottom, if I multiply my bottoms, I'll have 2 w to the 5th, x to the 7th, z to the 3rd. Okay, so now we're left with basically just one square root. So now what I want to do is simplify the fraction that I have there. So one of the skills that I didn't review was how we simplify division of like bases. So let's actually start though with the 8 and the 2. So notice that 2 is a factor of both 2 and a factor of 8. So if I divide top and bottom by 2, I end up with 4 over 1. Okay, if we look at our w's, well, notice I've got w to the 7th over w to the 5th. So I'm dividing top and I've got like bases, on the top and the bottom. So the way we handle that is we subtract the exponents. So I've got more factors of w on the top. So that means I'm going to be left over with w factors on the top. How many? Well, 7 minus 5 is 2. So I'm left with w squared. If we look at our x's, this time I have more x factors on the bottom than I have on the top. So I know I'm going to be left over with x's on the bottom. How many? Well, if I subtract 7 minus 3 is 4. So I'm left with x to the 4th on the bottom. And now if I look at the z's, well, I've got the same number of factors of z on the top as I have on the bottom. So that means if I divide out top and bottom by z to the 3rd, I end up with just a 1 and a 1, which means I don't have z's left over on the top or the bottom. So this is what I'm left with, this guy. All right, the next step then is I'm basically going to try to simplify this square root. So I'm going to look back to see how he did that by looking at number 3. So remember that my first job is to try to factor it, and then for every 2 factors of any particular type, I'm allowed to pull one out. So if we go back to our problem, well, what I know about 4 is that it can be factored into 2 times 2. W squared is just w times w. On the bottom, well, 1 times x to the 4th is just x to the 4th, so I don't really even need to worry about the 1. But I know x to the 4th is really just x times x times x times x. And now, again, what I'm looking for is for every 2 of each factor, I can pull 1 out. So when we look at our 2's, notice there we've got one group of 2 2's. That means I can pull a 2 out. Okay, if we look at our w's, I've got a group of 2 w's underneath my square root. That means I can pull a w out. Okay, on the bottom, let's look at our x's. So for our x's, it looks like I've got one group of 2, 2 groups of 2. So I can pull out 2 factors of x, which means I'm going to be left with x squared on the bottom. And notice I've used up all of my factors underneath the square root. So there's going to be nothing left under my square root. So this is going to be my final answer. One thing I will make a special point of emphasis about is that notice that my x's started out on the bottom in this step. Well, then in my answer, my x's, whatever I pull out, needs to be on the bottom. Same thing with these guys. They started out on the top, so when I pull them out, they need to be in the numerator position of my rational expression.